You hold a magnet in each hand and slowly bring them closer. Before they ever touch, you feel it, that strange resistance, like pressing against an invisible wall. Turn one magnet around and suddenly the resistance vanishes. Instead, the magnets rush toward each other and collide with a sharp, surprising snap. The experience is immediate, physical, almost alive. It invites a question that feels both innocent and profound. Why? What is actually happening in the empty space between your hands? The moment you ask why, you step onto a ladder that seems to descend forever. You are looking for an explanation that feels solid, something built from ideas you already trust. Perhaps you think there are invisible strings or rubber bands stretching between the magnets, pulling or pushing them apart. But that explanation is only a verbal illusion. If invisible rubber bands exist, the next question instantly appears. Why do rubber bands pull in the first place? To answer that, we would need to talk about molecules, atoms, and the forces holding them together. And those forces turn out to be the very electromagnetic interactions we were trying to explain from the start. At that point, the explanation collapses into a loop. One mystery is being used to hide another. The words change, but the understanding does not deepen. This is not insight. It is a clever rearrangement of ignorance. Real understanding feels like firm ground. Here the ground keeps slipping away. The surprising truth is that the force behind magnetism is not foreign to you at all. You are already deeply familiar with it. You encounter it constantly, every waking moment of your life. The only reason it feels mysterious is because it has become so ordinary that you no longer notice it. Place your hand flat on a table. The surface feels solid, rigid, unquestionable. It seems obvious that your skin is touching the wood. But on the most fundamental level, that is not what is happening. Not even close. As your hand approaches the table, the electrons surrounding the atoms in your skin encounter the electrons surrounding the atoms in the table. These clouds of negative charge repel each other with immense strength. That repulsion prevents your hand from passing through the table. The sensation you interpret as touch, the feeling of hardness, resistance, solidity, is nothing more than electromagnetic force at work. There is no true contact. There is only repulsion. The same fundamental interaction that makes magnets push and pull is what allows you to sit on a chair, walk on the ground, and type on a keyboard. The table beneath your hand is no less mysterious than the magnet in your grip. You have simply grown accustomed to it. This familiarity dulls your sense of wonder. The magnet feels special because it exposes the force directly. It lets you feel electromagnetism without disguise, acting across empty space, visible and undeniable. In everyday objects, that same force is hidden behind balance and symmetry. In magnets, the balance is broken. Most of the electromagnetic power in the universe is locked away, perfectly neutralized. Every atom contains positively charged protons in its nucleus and negatively charged electrons orbiting around it. Under normal conditions, these charges cancel each other out. From the outside, the atom appears electrically neutral. Vast forces are present, but they are paired off so precisely that they vanish from view. Magnetism arises when this delicate cancellation is disrupted in a very specific way. Inside certain materials like iron, the tiny magnetic properties of individual electrons can line up instead of canceling out. When enough of them align, their effects add together. What was once hidden becomes visible. The magnet becomes a window into a force that otherwise remains concealed. This is why a magnet feels so uncanny. It allows you to sense a universal interaction directly without the usual camouflage of neutrality. It reaches across space and announces itself through motion and resistance. It reminds you that empty space is not empty at all. It is filled with structure, rules, and invisible influence. And yet, when we ask the deepest version of the question, why does the electromagnetic force exist at all? The ladder drops away beneath our feet. Physics can describe how the force behaves with extraordinary precision. It can calculate exactly how strong it is, how it changes with distance, and how it shapes the structure of matter. But when we demand a reason that rests on something more fundamental, there is nowhere left to stand. We are tempted to keep digging, to demand a deeper mechanism beneath the force itself. But at some point, every explanation must end. In modern physics, electromagnetic interaction is not explained in terms of something simpler. It is one of the basic rules of the universe. It is part of the foundation, not something built on top of it. This can feel unsatisfying, even unsettling. We are used to explanations that reduce complex things to simpler ones, but nature does not promise that everything will reduce forever. Sometimes the universe simply says, this is how it is. Magnets feel magical because they bring us face to face with this fact. They expose a fundamental ingredient of reality that normally hides behind the scenes. They make the invisible tangible. They let you feel, quite literally, the rules that hold atoms together and prevent the world from collapsing into nothingness. In that sense, magnetism is not strange at all. It is the rule, not the exception. What is strange is that we forget this. We stop asking questions about tables and floors and walls because they feel familiar. But familiarity is not the same as understanding. The magnet jolts us awake. It reminds us that the world we live in is not built from solid stuff in the way we imagine. It is built from forces, balances, and interactions acting across space. What feels solid is, at its core, a delicate standoff between electric charges. So when you feel that invisible barrier between two magnets, you are not encountering something exotic or rare. You are touching the same force that gives shape to your body, strength to the ground beneath your feet, and structure to every object you have ever known. The magnet only feels special because, for a moment, it makes the ordinary visible and reveals just how deeply mysterious the everyday world truly is. In most materials, this charge is exquisitely balanced: positive, neutralizing, negative. The force is there, monstrously strong in fact, but it's hiding in plain sight. Consider its strength. The gravitational pull that holds planets in orbit is pathetically feeble compared to the electromagnetic force. The difference isn't a factor of 2 or 1,000. It's an almost unimaginably large factor. It's an absurd, incomprehensible dominance. We don't fly apart or crush together because every bit of positive charge is neatly matched by a negative charge. The universe's most powerful engine is idling silently all around us. A magnet is a place where this balance is orchestrated to create a directed external effect. It happens in materials like iron, cobalt, or nickel. Inside every atom, electrons spin, and this spin creates a tiny magnetic field. In most substances, these spins are chaotic, pointing in every direction, their effects canceling each other out into magnetic silence. But in iron, under the right conditions, these tiny spins can line up billions upon billions of them, all pointing the same way. Imagine a stadium where everyone whispers randomly. You hear only a murmur. Now imagine everyone chants in unison. The sound carries for miles. The individual voices haven't changed, but their coordination creates a power that propagates far beyond the individual. That is ferromagnetism. The aligned spins no longer cancel. They amplify, summing into a collective field you can feel sent them away. But this only describes the source of the field. What is the field itself? What actually transmits the push or pull across that empty space? Here our everyday intuition completely fails, and we must descend to the most fundamental floor of reality quantum mechanics provides. At this level, the story is told not with forces like tugs or pushes, but with exchanges. The electrons in the aligned atoms of one magnet are constantly hurling tiny packets of energy and momentum at the world. These are not photons of light you can see. They are virtual photons, fleeting messengers that exist only for the duration of the interaction. An electron in one magnet emits such a virtual photon. An electron in the other magnet absorbs it. This exchange of a messenger particle is the force. The repulsion or attraction you feel is the summed effect of trillions of these unseen transactions happening every nancond in the space between the magnets. The breathtaking simplicity of our modern understanding is that all electromagnetic phenomena, every spark, every color, every chemical bond, every solid object, and every magnetic pull arise from just 3 primitive actions. A photon goes from one place to another, an electron goes from one place to another, and an electron emits or absorbs a photon. That's the entire rule book. There are no hidden gears, no secret machinery beneath this stage. The complex tapestry of our physical world is woven entirely from these 3 threads. Our mastery of this is not philosophical. It is mathematical and stunningly precise. In 1873, James Clerk Maxwell wove electricity and magnetism into a single elegant tapestry of equations, revealing them as two faces of one phenomenon, electromagnetism. This understanding lit up the world. We learned that a moving electric field creates a magnetic field, and a changing magnetic field creates an electric field. This dance is why you can spin a magnet near a coil of wire and generate a current, or send a current through a wire and create a magnetic field that spins a motor. Our entire technological civilization, from the dam generating power to the light on your screen, is built on this orchestrated dance of copper and iron guided by Maxwell's equations. Even deeper, quantum electrodynamics, the theory that describes these photon exchanges, allows us to calculate magnetic properties with almost ludicrous accuracy. We can predict the magnetic behavior of an electron so precisely that the theoretical prediction matches experimental results as closely as measuring the distance from New York to Los Angeles and being off by less than the width of a human. Hair, it is the most successful and accurate predictive framework in human history. And it is all about the force you feel between those two magnets. And yet, for all this predictive power, profound mysteries remain. There is a number approximately 1 over 137 known as the fine structure constant. This number sets the strength of the electromagnetic interaction. It determines how strongly electrons are bound to nuclei, how strongly magnets attract, and the very rules of chemistry. We can measure it exquisitely, but we cannot derive it from any deeper principle. We do not know why it is 1 over 137 and not 1 over 200 or 110th. If this force were even slightly altered, the universe as we know it would unravel. Atoms would fail to bind. Molecules would never form. Chemistry, the intricate dance that makes stars burn, planets solidify, and life emerge, would simply not exist. The cosmos would be cold, inert, and empty. The simple fact that you can stand here, holding a magnet and feeling it push back against your hand, depends on a single, deeply mysterious number embedded in the laws of nature. It is a quiet parameter written into the fabric of reality for reasons we do not understand, yet upon which everything depends. This realization leads us to the most humbling truth about magnets and about understanding the universe at all. Human intuition did not evolve to grasp the quantum world. Our minds were shaped to deal with falling rocks, flowing water, and objects moving at everyday speeds. But the realm beneath those experiences is profoundly alien. It is a domain where particles behave like waves, where outcomes are described by probabilities rather than certainties, and where forces arise from the exchange of fleeting, invisible messengers. Expecting this world to make intuitive sense is like expecting a bat to visualize color or a fish to understand fire. We have no accurate mental picture of an electron. It is not a tiny solid sphere orbiting like a planet. It is not quite a wave spreading through space. It is not a fuzzy cloud in the way clouds exist in the sky. The electron simply is, and the only faithful description of its behavior is mathematical. The equations tell us how it moves, how it interacts, and how it responds to forces, and they do so with breathtaking accuracy. But the equations are not illustrations. The math does not translate into a comforting picture. In a very real sense, the mathematics is the picture. We are like an extraordinarily talented blind calculator, able to predict with absolute precision when and where a ball will land, yet unable to describe the color of the sky it flies through. Our calculations are flawless. Our intuition remains mute. Now return to the magnet in your hands. When you feel it resist your push, what are you actually sensing? You are feeling the electromagnetic force, one of the fundamental pillars upon which reality rests. You are feeling the collective alignment of vast numbers of electron spins inside the magnet. You are feeling the effect of countless virtual particles being exchanged across the apparent emptiness between your hands. Nothing mystical is occurring, but nothing simple either. This is the same force that gives your bones their rigidity and your muscles their strength. It is the same force that allows nerves to transmit signals, letting you think, feel, and move. It is what makes fire burn, ice feel cold, and light interact with your eyes. Magnetism is not a special trick layered on top of reality. It is one of the core explanations from which nearly everything else follows. The magnet feels extraordinary because it strips away the disguise. In ordinary matter, electromagnetic forces are so perfectly balanced that they cancel out almost entirely. Every atom contains positive charge in its nucleus and negative charge in its surrounding electrons, arranged in such a way that their effects mostly neutralize one another. The immense forces are there, but they are locked in stalemate, hidden from direct experience. A magnet breaks that symmetry. Inside it, countless tiny magnetic contributions, normally pointing in random directions, line up. Their effects no longer cancel. They add. What was buried becomes exposed. The magnet reveals, at human scale, a force that usually operates invisibly within the atomic machinery of all matter. That is the magnet's true magic. It pulls back the curtain. It takes the force responsible for every touch, every solid surface, every physical sensation, and makes it unmistakably real to your senses. It allows you to feel directly and without mediation one of the universe's fundamental rules. And yet when we push our questions further, when we ask why this force exists at all, or why it has precisely the strength it does, we reach the edge of explanation. Physics can tell us how electromagnetism behaves. It can predict its effects with stunning accuracy. But it cannot tell us why reality chose these rules instead of others. There is no deeper mechanism waiting beneath them. At some point, the ladder of why simply ends. This can be deeply uncomfortable. We crave explanations that rest on familiar ideas, on metaphors we can grasp and visualize. But here, the universe offers no such comfort. The electromagnetic force is not explained by something simpler. It is one of the simplest things, one of the foundational facts from which complexity grows. Magnets confront us with this truth in the most direct way possible. They show us that the everyday world is not built from solid stuff pressing against solid stuff, but from invisible forces maintaining delicate balances across space. What feels firm and reliable is, at its core, a dynamic standoff between charges that never truly touch. So when two magnets repel, you are not encountering something exotic or rare. You are encountering the same force that prevents your hand from falling through the table, that keeps atoms from collapsing, that allows the universe to have structure at all. The magnet only feels special because it reminds you of something you usually take for granted. The mystery, then, is not hidden inside the magnet. The magnet is a keyhole. When you look through it, you glimpse the deeper reality beneath your everyday experiences, a reality that is mathematical, precise, elegant, and profoundly strange. In that narrow space between your hands where nothing seems to be, the engine of the universe hums silently, doing exactly what it has always done, whether we understand it or not.